This is Mrs. O'Neill for AP Chemistry, Chapter 10, Section 6, Gas Mixtures and Partial Pressures. In this section, you'll recognize that in a mixture of gases, each gas exerts a pressure that is part of the total pressure in that container. And we're going to apply this partial pressure as if the pressure of that gas was exerted by itself. So pause the video, fill in the blanks, and then play to hear my words. This should make sense. The total pressure in a container is going to be the sum of all the pressures of each gas that's in that container. So on your reference sheets, you have something that says the total pressure equals pressure 1 plus pressure 2 plus all the pressures of those gases. We want to remember, though, to find the gas pressure of those individual gases, you might have to use PV equals nRT and then add up all those pressures. So it might be a multiple step problem. Mole fraction. So moles of a component or moles of one compound over the total moles of all the compounds or elements in that mixture. Again, it's a mole ratio. So you should know this, and it's on your reference sheets as well. Pressure of a gas, this is just a different equation. So pressure of a gas is going to equal the pressure total times that mole fraction. Again, this is on your reference sheet. So sometimes you have to find the mole fraction, sometimes you have to find the top part of the mole fraction, sometimes you have to find the bottom part of the mole fraction, sometimes you have to find the total pressure, and sometimes you're going to use the equation as is. The pressure of the gas, whatever gas we're interested in, is going to be the total pressure in that container times that mole fraction of that particular gas. So sometimes you collect gas over water, but we want to remember that water evaporates. So if water evaporates, that means there is vapor pressure from the H2O also mixed in with the gas, whatever we collected. So if we want the gas pressure, the pressure of the gas only, we have to subtract the pressure of that vapor, the water pressure, in order to get the true value of the pressure of the gas. So that should actually make sense. Again, if it's a mixture of gases, the total pressure is going to equal the pressure of the gas that we're collecting as well as the vapor pressure of the water that's evaporated. So we're going to do some subtracting. So get out a piece of paper if you don't have one already and try to do these problems. So this is what I suggest. Pause the video, do the problems either one at a time or all at once, do as much as you can. Play the video to see the answers and the solutions. I also have come up with a game plan. So I've given you some step-by-step game plan and then step-by-step solutions. So you might want to kind of play and pause, and if you get stuck along the way, you can kind of adjust to that. And we want to remember that your temperature always has to be in the Kelvin unit. And again, remember your R. If you're using your PV equals nRT, remember that you need certain values for that as well. So for number 1, read over, pause, try to do it, and here's my game plan. Here's the solution. And now we're moving on to the next part. Hopefully you got that answer, and we'll do some book work as well when we get to class. Number 2. That one again is kind of simple. Again, the total pressure in that container is going to equal the total pressure of each individual gases added up, but we are given the total pressure and we're given the pressure of the other gases, so now we're actually subtracting, just rearranging that equation. Number 3, game plan. And solution. And it did ask for millimeters of mercury, so you might have used a different value of R and already got the millimeters of mercury, but I am just so used to using 0.0821, so I always use that. I know it's in atmospheres, and then I convert to millimeters of mercury. Number 4 is game plan. And the solution. Number 5's game plan. So again, this one's a little tricky because you're finding that top number of that mole fraction, something that you might see later on a test possibly, or quiz. And hopefully that makes sense. 6 games plan. And the solution. Number 7. That's pretty straightforward. Number 8. Little stoichiometry it looks like because there's a reaction. Let's see. Here's the game plan. There's that stoichiometry word. And the solution. See you in class to do some bookwork.